So an unknown compound was determined to be 74.97 carbon, 8.39 hydrogen, and 16.64 oxygen. Calculate the empirical formula. So I have percent composition here. It's this question. So I have 74.97% of carbon, 8.39% hydrogen, 16.64% oxygen. And then this all adds up to 100%, right? So how would you figure out what the empirical formula is? Well, I'm going to assume my sample has 100 grams, and that's the easiest way to do this assumption. So I can assume 100 grams. And basically, this converts all of these guys here into mass, right? So I have 74.97 grams of carbon, 8.39 grams of hydrogen, and 16.64 grams of oxygen here. And what I can do now is I can find the moles, right? Because the moles are the very, very important part because it shows me the proportion in an empirical formula. So I'm simply going to multiply that by the molar mass, right? Or sorry, divide by the molar mass here. So I have grams here and I have grams per mole. So I'm going to divide by the molar mass, right? So this will be, I'm dividing, again, moles equals mass over molar mass here. So let me write that down here as my formula. So we call that moles equals mass divided by molar mass. So I'm dividing here by the molar mass because I already have the mass here. So I'm dividing by, in this case, this is 12. Oh, that's a different color here. It's okay. 12 grams per mole. Hydrogen is about 1.008 grams per mole. And oxygen here is 15.999 grams per mole. And you can double check that if you wanted to in the periodic table. Again, carbon is 12.011. Actually, let me do 12.001. Actually, it might be a bit better for us. Just so I don't do a rounding error here. It's 12.011 grams per mole. Hydrogen is 1.008, like I said before, and oxygen is 15.999, right? So this is good. And then we're simply just dividing these numbers here to get our moles. So we do that in my calculator. I have 74.97 divided by 12.011. Give me a value of 6.24. And this is moles. Hydrogen, I have 8.39 divided by 1.008. Give me a value of 8.32. And then finally, oxygen here is, I'm dividing by 16.64 divided by 16 is approximately 1. So I'm going to say 1.0 moles here. And what we can do with these values is this is simply the proportion in our empirical formula, right? So we can say that we have this common formula here. We have C, X, H, Y, and O, Z here as our chemical formula. And as you can see, we take the smallest number here, which is 1.0, and we're going to divide it out by these guys here to get the proportion, right? So we're going to have, so with oxygen, we're simply going to have one oxygen because we're going to divide by our 1 mole, right? So if we divide by 1 mole, we're going to get 1 here. If we divide 6.24 by 1, we're going to get 6, right? So again, this value here is going to give me 6, right? So this, if I divide by 1, it's going to give me 6, and this one is about 3, and this is approximately about 6 and 8 here. So therefore, our formula here is simply, so I'm going to have C6H8O, and that's going to be our empirical formula for this problem here. So as you can see, they divided it by the mole ratio as well. And so divide by 1, divide this by 1, and this by 1. So you get 6, 8, and 1, and these are the proportions for the empirical formula. So C6H8O. So the solution is correct.